welcome right back to the live stage, right here in the hub, Microsoft Build. I am here with some good friends from Intel. I've got Saurabh and I've got Guy, and we are talking a little bit about unleashing superpowers of AI PC. All right, talk to me. Superpowers.
Absolutely, Joey. Thanks for having us today.
Thanks for being here.
Today is an amazing day. We couldn't trade it for anything else. Very inspired by the talk, that keynote that Satya gave today.
Yep.
All about unleashing co-pilots. And we're here to talk about the superpowers that you have to run on AI PC, all this brilliant AI that people are going to bring up. We have the superpowers of GPU, NPU, and CPU working together. AI, as we see it, it's not just about being able to run one appliance at a time. It's about real-world AI. Being able to run the same AI differently. AI comes in all shapes and sizes, so that's what it's all about. Now, what we are here to talk about are the capabilities that are already built into a platform. Okay. Especially now coming into this new age of co-pilots, what you need is essentially a pipeline, AI pipeline of ingredients or capabilities that are working together. You have a static LLM model, which was trained on a static knowledge base. But now you're able to augment that ability by running a RAG pipeline to it. Mm-hmm. You're augmenting its ability to do more. And then, we've all seen a lot of these demos of static chatting between LLMs and you. We're talking more about whether we can do some action on top of it. So to give you an example here, it's a consumer scenario that you're looking at. We have such question all the time. Did I spend more than my budget? Now, what you're able to do is bring in your private data, be able to analyze it using an LLM, a bleeding edge LLM, all happening on your PC. So it's secure, you can trust something on these lines. And then what you're able to do is extract some knowledge and action out of it. This action element is very novel. I'm super excited about. This is the first time what we are doing is showcasing this complete pipeline running from RAG to LLM to React reasoning, all running on your PC. It's fairly interesting. It's very bleeding edge, so that's why I'm going to invite my colleague here, the guy, to take us further. He's our top researcher at Intel who's been driving some of this work. Go ahead, Guy.
Thank you. Okay, so today we would like to talk about the great experience with 5.3 powered by Intel Core Ultra processor. We will go over 4 different demonstrations. The first demo is 5.3 agent with React prompting. In this demo, we will see how 5.3 is an agent that can respond to user query and that can reason and take actions according to the user query. In the second demo, talk with your private data, we will see how users can talk to the document and get an answer with retrieval augmented generation. Then we will see 5.2 inference acceleration with quantization and speculative decoding. And in the last demo, we will see the multimodal Lava 5.3. Now, for most of the demos that you see here, we released an open source Python notebook. So I really invite you to reproduce the results and get the great experience that we will show you today. Probably I will not have time to go over the third demo, so I invite you to our booth to watch all the demos. Okay, so let's start with the 5.3 React agent. So prompt are the instructions and context that user provides to a language model in order to achieve a desired task. It can be chat or question answering. React prompting was first introduced last year by Princeton University and Google Research. It's a new prompting approach, and React stands for reasoning and acting. This method allows LLM to go beyond the simple text generation. Yep. It's actually allowed LLM to use tools and perform actions to better address the user's input. It allows LLM, as you can see in the diagram, to incorporate tools such as retrieval augmented generation, Gmail, Wikipedia, Bing search, and more. Please note that some of the tools can access your own private data on device, and some of the tools can access the internet. Okay, let's have a look at the diagram again. So in the first phase, we insert the user query into the React template prompt. Then we inject this prompt into the agent. This is what you see in the middle. Now the agent decides whether it needs to use a tool in order to answer the user query. If a tool is needed, it calls the tool, and then the output of the tool goes back to the prompt. The prompt goes back again to the agent. Now the agent can decide that it needs to use another tool in order to answer this question, and the process goes back again. Only when the agent decides that it has all the information to answer the user query, it will generate the answer. OK, so let's have a look at the demo, how it works. So for our demo that we will show you here, we use two different tools. We use Retrieval Augmented Generation and Gmail. For the Retrieval Augmented Generation, we indexed 150 BBC Sport News articles. So I'm going to show, I'm going to ask how many teams will the Champions League feature this year? This is the question. And as you can see in the first line, labeled by thought, the agent reasons and understands that it needs to use a tool in order to answer the question, right? So it used RAG. It answered the question, along with the references it used to answer this question. This is what you see, the text in the gray text. And then I'm going to ask the agent, send this answer over Gmail. And now you'll see again that the agent understands that it needs to use another tool, which is Gmail, in order to answer this question.
So this agent here, I mean, it looks really smart to me. It's making a lot of these decisions
really
for you.
Smart. Yeah.
Very cool. Very cool.
OK, so let's move forward. Retrieval Augmented Generation with 5.3. So Retrieval Augmented Generation allows LLM to access external knowledge by injecting retrieved information. Let's have a look at the diagram to see how it works. So first, the user indexed tens or even thousands of files on device. These files are being embedded, indexed, and saved into a vector DB. Now, once the user provides a query, we retrieve the information from the database, and we create new unified new prompt, which is composed from the user query and from the retrieved information. We inject this prompt to the LLM and generate the answer. So RAG has several advantages. So first, it augments the LLM knowledge without the need to train the model. Second, there is efficient use of data, right? Because we do not feed the whole document, we just feed the retrieved information. It reduces hallucination, and it improves the reliability of the models, because when it gives the answer, it quotes and refers to the relevant data where it took the answer from. Let's see how it works in the demo. So I'm going to use the same BBC Sport News article for this demo.
Sure.
But this time, I'm going to talk to the machine, right? And
OK, yeah.
type. So as you can see, in the first time, I'm not using RAG, and the answer is wrong. The answer is 32 teams, and the correct answer is 36 teams. So I'm going to ask the question again with RAG, with Retrieval Augmented Generation, and the answer now is correct.
So you've taught me something, because I didn't know the Champions League championship had expanded teams. But secondly, I'm really curious, how does this actually run on the Intel Core Ultra processor?
Yeah, so I believe this is a great example to show developers how they can leverage our software stack to split the work between NPU, CPU, and integrated GPU. Because what we see here is that the Whisper algorithm, the speech recognition, is running on the NPU.
OK.
The 5.3 inference running on the integrated GPU. And the database search is running on the CPU. So this is a great example. OK, so let's move forward to the Llama 5.3 model demo. So Llama 5.3 was trained with vision encoder. So the model can handle multimodal tasks that involve text and images. And what I'm going to show you in the next slide is visual question answering. So I'm going to insert an image, and I'm going to ask the model to describe the scene. So as you can see, the model has detailed understanding of the scene, very good understanding of the scene. It even recommends this place for fishing or simply relaxing. Okay, so let's have a quick. Okay, so let's have a quick look at on the code. So this is one of the core parts of the code. This is the LLM inference part. So I just want to show you how easy it to run Phi3 and actually LLM inference on the Intel Core Ultra processor. So you just need to define the name of the model. You define the quantization config. Here we are using 4-bit quantization. You need to load the model. You load the tokenizer. Then here we give some sample. We tokenize the sample. We tokenize the input, and we just call generate. Okay? And in this case, we use OpenVino. So it's very easy. And for developers who would like to use Onyx with DirectML, the flow is very similar and very easy. Just define the name of the model, load the tokenizer, define your sample input, and just call generate. Very easy to run.
Very cool. Very cool.
Awesome. Thank you, Guy. Thanks for helping us. As you saw, this was quite a performance of the AI PC running an LLM together. So this is where I would really want to emphasize that what we are looking for is real-world AI.
Yeah.
Real-world AI has 4 pillars. It's efficiency, there is security, then you have the ability to work with the web, and what you really want after that is also developer readiness. If you can have all 3, but if you're not ready for developers, you would not be able to innovate on that platform. Right? When I mean efficiency, it means being able to run with the longer battery life.
Yes.
We're not going after a fallacy of just teraflops and flops. And which is true, right?
For sure,
like
for sure.
AI comes in all shapes and sizes.
Yep.
You can have models which will do brilliant on running on CPU,
yeah.
right? And then there are scenarios which will do really well on GPU, especially things like stable diffusion.
Right.
So at the end of the day, what we really want is customer experience, the user experience. Mm-hmm. And I heard Rajesh said that earlier also. It's about natural language interface coming together with graphics user interface. So at the end of the day, it's experience that we are shooting for, not a fallacy of a tops or a flops. Secondly, it's very important for us to ensure there's security element to it. You would not be able to handle AI well on a platform if you don't have the security aspects covered, right?
100%. You don't need to talk to me about security. Well, we'll talk more later.
Absolutely. And then the other element of real-world AI is it needs to be web-ready. And you would hear from Mo in the next session also how AI PC from Intel and the NPU especially is really ready for web, right? We have a standard. We have worked for years with Microsoft defining standards like Onyx and Onyx Runtime and WebNN. Right? So these are the things where you would see real-world AI really come together for you. And developer readiness, I cannot say more about it. There was a running demo of a bleeding-edge, state-of-the-art thing, research that was come, and it's running solely on a PC environment.
And you have the example code.
Exactly.
You're ready to take on the developers right now.
Exactly. So
awesome.
Whether you like PyTorch, and I don't know if it was mentioned earlier, the demo had DirectML running, it had OpenVino running, and the models were trained using PyTorch. So we are really meeting the developers where they are, right? So we're really lowering the bar to come and innovate on our platform without having to go online and use the cloud for it. Everything is here on your AI PC to run LLMs, RAGs, and being able to act on them using React reasoning.
Making all of those decisions, taking into account those 4 big things. Super cool, super great stuff.
Yeah.
Guys, Saurabh, thank you so very much for joining us. And for those of you here in the room, and also for those of you online, you want more information about this Intel cool stuff that we've just seen. You want to see the code? We have an answer for you. It is called the Feature Partner Directory. It's located right there on the build.microsoft website. You can go there, you can hit that link, you can take a look at all the things, and if you happen to be sitting here in the audience, go harass these guys, learn more, go see that code, gather it, and move forward.
Absolutely.
Thank you so very much.
Thank you.
We are going to be right back with more from Microsoft Build in just a moment.